Like Rick mentioned, I am Erica Carroll. I am the Training and Education Manager here at Atlona, and I am excited to be talking to you guys about HDR signals and transmission mediums, including our Opus series of switchers. So first, let's get started with some basic learning. So let's begin by answering the question, what is HDR? And to begin this is to understand that HDR is not one thing, but it is several features that all work together to produce a highly appealing visual image. HDR content on HDR compatible TVs can get brighter and darker at the same time and show more shades of gray in between. Similarly, these displays can produce deeper and more vivid reds, greens, blues, and show more shades in between. Some of your customers might ask, why do I want HDR? And aside from telling them that the picture looks incredible, you can back that up by giving them a comparison. For example, if you put two TVs side by side, and one has a better contrast ratio and more accurate color, and the other just has a higher resolution, which is just more pixels, the one with greater contrast ratio and color will be picked by pretty much every viewer as the better looking image, and that image will look more neutral, pop more, and just seem more real. So even when compared to a display with lower resolution, in other words, a 1080p resolution TV with excellent contrast and color always beats a 4K resolution TV with average contrast and color every time. So let's go ahead and break down what makes up this entire bandwidth, what goes into that signal. Let's start with pixels. With high def, we had images that were 1920 by 1080, and that's about 2 million pixels. 4K is 3840 by 2160, which is about 8 million pixels. So that means 4 times the data is going into that transmission. And now with color, we have a wider range of color information that's available and being sent. And along with more color, we also have to consider color depth or bit depth. And that would be the amount of available color we're giving to each pixel in the display. And this would be defined as 8-bit, 10-bit, or 12-bit. And finally is the refresh rate. And the more we refresh that image, the smoother the image is, for sure, but also the more data we will be transmitting over that signal. So when all of these come together, it's described as this, right? 4K 60 hertz, 420 8-bit, and we'll cover that in just a second. And then the bandwidth required to send all of that 10 gigabits per second. So when we break it down, 4K is how many pixels, 60 is the refresh rate, 420 is how many pixels will receive its own individual color information. 8-bit is how many colors will those individual pixels receive, and 10 gigabits is the bandwidth needed to carry that load. So I want to talk about chroma subsampling because this is something that's sort of skimmed over many times. So we've all heard 444, 422, and 420. So I want to cover what that means exactly. And if you'll notice in our top left example here, we have 444, and this ratio is a sampling to A to B. So we're going to be sampling 4 pixels. That's 1, 2, 3, 4, 1, 2, 3, 4, and then in row A and row B. Now, every single one of these samples receives its own luminance information. That's how bright that pixel is going to get, right? But the difference comes in these last two numbers. So it's not always going to be 4, 4, or 2, 2. So just to walk you through this, we have 4 pixels, 1, 2, 3, 4. And then the first row, this 4, is signified by this A. So this is 1, 2, 3, 4. All 4 of these pixels are receiving their own chrominance and their own luminance information. And the second 4 is for this B sample line. So every single one of these is getting its own luminance and its own chrominance information. So this is the highest amount of data that that pixel can actually get as far as chrominance and luminance. So if we go down here to 422, every single one, again, this 4, everyone is getting their own luminance information. But in this case, for this first 2, we'll look at row A. we only have 2 pixels receiving their own information, not these 2 right there. And so you'll notice that these 2 colors are similar, but they have their own luminance information. So same thing down here. For row B, we have 2, so it'd be 1 and 2. So they get their own chrominance information. So that's about half the amount of information that's going into the 444. And further still, if we continue to compress that pixel color, each one again is receiving its own luminance information, but only 2 pixels in row A are receiving their own chrominance and none in row B. So they are all sharing the same chrominance information, compressing that color information. So if you have any questions on that, we can go over that later also. So now I want to talk about 8-bit color, or at least the color gamut here. So when you say 8-bit color, that means 16.7 million colors are available to each one of these individual pixels. That's a lot of information. So when you have a lower chroma subsampling, but a higher color depth, bit depth, 12-bit color would be 68 billion colors available to each one of these pixels. So in this case, it would only be 2 pixels. Up here, it would be 68 billion colors available to each of these 8 pixels. Okay. So when we start to look at that in terms of bandwidth, I want to look here at this 4K 60 420 10-bit color. And this takes about 11.14 gigabits of data. Okay. Now, if we take it up, that's a standard HDR. Okay. If we take it up a step from there, we have 4K 60, 420 still, but more color information, so more data is being sent to these compressed pixels. We're at 13.37. And one step further from that, 4K 60, 422, so a little bit less compression, more color information, still the same as the color information that's above here at 12-bit color, and we jump skyrocket to 17.82 gigs of bandwidth that's needed to support that signal. And so what that looks like in the technology and the cables that we're using currently, if you see this, HDMI 1.4 and H2BaseT are limited to 10.2 gigabits. So when you're looking at HDR video, you want to make sure you're speccing in that HDMI 2.0 cable to make sure it fits within that bandwidth limitation of 18 gigabits. Now let's change the conversation and talk a little bit about HDR and the dynamic range portion of HDR. And the first thing we talk about there would be contrast ratio. And why contrast ratio is so important is because the changes in contrast ratio are perceived more closely by the human eye. In other words, changes in the darks and the lights are what our eyes notice the most, more so than color gamut, more so than color accuracy, and even resolution. Contrast is the most important to the human eye. In fact, resolution is down at the bottom, based on, viewing distance or even size of the display. The resolution is, has minimal impact as opposed to the contrast that's in a display. So what is contrast ratio? We've all seen this, right? It's the brightest white and the darkest black. And excuse me, that a display can create. And high dynamic range offers a wider range of blackest blacks and whitest whites that a display can create, and so that creates a larger gap, which is a higher contrast ratio for that display. Another term we need to get familiar with HDR is nits. So nits is another measurement of brightness. Now, we've also looked at foot lamberts in the past. We've calibrated in foot lamberts. A standard display are about 100 foot lamberts, which is only 340 nits. And for a display to be HDR, it needs to be a minimum of 1,000 nits in peak brightness so that it has that wider range of whiter whites and blacker blacks. And we've all seen this color diagram here. Now you see Rec 709 is that center triangle. This is familiar to us. We've been calibrating to it for years. There is a wide range of colors there, but there's been quite an advancement since we've been calibrating for Rec 709. We do have DCIP3. This is more used in digital cinema. That's that center solid triangle. And now we have ITU 2020 or Rec 2020, which is that larger triangle. So this is about 98% of all the colors that a human eye can see. And as we're calibrating to those exact points, you'll notice the conical shape on the right there is actually more a better representation of HDR because it actually shows the brights and the whites. You do have chrominance calibration, but then you also need to incorporate, the depth of that luminance as well. So how does HDR work? There are two main components to HDR. First is the display. The display needs to be able to produce more light than a standard display. So it needs to be HDR compatible, and the source or the content also needs to be HDR compatible, as well as this would be a direct connection. But if you have another system with multiple components in place, you need all those other components to also be able to handle the HDR metadata. So what is HDR metadata, and how is that information transmitted? So HDR uses metadata, which is information that's layered on top of that video image. And it tells the HDR compatible display how to best take advantage of the greater color and contrast range in the underlying video image. Now, there's two different ways to use HDR metadata. There's static metadata and there's dynamic metadata, which is more HLG also, which we'll get into that in just a second. So static metadata is, if you can imagine you're watching a movie, and the metadata is just put on top of that content, and it's static. It's set at the beginning of the movie, and those settings are set for the rest of the movie. Dynamic metadata takes a little bit more complexity in that HDMI 2.0B and allows each scene to have its own metadata. So the dynamic metadata is changing with the content so that you actually get the best viewing out of each individual scene. There's a few different types of HDR formats. First is HDR10. So HDR10 has supports up to 4,000 nits and has a 10-bit color depth and capable of displaying everything within Rec 2020 color space. Next is Dolby Vision, which supports up to 10,000 nits, so more than twice the peak brightness of HDR10, and provides more color at 12-bit color depth, and also capable of displaying everything in the Rec 2020 color space. And now we have HLG, which is hybrid log gamma. And this is a different kind of HDR. It's actually made for broadcast cable, satellite, and live TV. So with HLG, the metadata is actually encoded into the broadcast signal, and only HDR capable displays will be able to receive and recognize, use that signal. So there are a few Atlona products that take advantage of HDR. So first up is OmniStream R-Type for sending HDR over a network. Next up is the H2H, which is an HDMI to HDMI switcher, and this comes in the 8x8 format and the 4x4 format. We have a transmitter kit. We have a few transmitter kits. First is the 100 CEA, that's 100 meters with control Ethernet and audio return channel. We have the 70C, which is a 70 meter kit with control, and then just a regular 70 meter kit for audio and video. We have the Juno series of switchers, which we'll touch on in just a moment. The Etude Sync is an ETID emulator for 4K HDR HDMI signals. And then we have the Rondo series, which is a 2-output and 4-output HDMI DA. And then we have our HDR M2C and M2C Quad, which is a multi-channel to 2-channel audio converter. And the Quad is just like the regular M2C, but it's essentially 4 chassis in one. So one power supply in order to run all of that. And to top it off, we have our new Opus line. And Opus and OmniStream R-Type both right now have the ability to handle and stream Dolby Vision HDR signals. Opus is the new version of our Pro 3 series, and it's completely expandable. So let's go ahead and jump into that. So these Opus series of switchers come in a 4x6, a 6x8, and an 8x10 chassis. Now, 2 of the outputs on each one of these chassis, the last 2 outputs, are actually HDMI out, so you can use them locally, or you can throw an extender set on there in order to get it to reach other ports of the room. They are all H2.0 ready. They support all the HDR formats we talked about, HDR10, HLG, hybrid log gamma, and Dolby Vision. Now, they're also an any-to-any audio matrix. This is a request that we received many times, so you're able to route that audio to any output. And there is an integrated HD-based health monitor on these also. So when you log into the web GUI, you can monitor the signal strength and the health of the HD-based cable and of the endpoint that it's connected to. So for receivers on those switchers, first is the Opus RX. This is an HD-based receiver for all of those HDR formats and up to 100 meters. And then I want to point out the Juno 451. So you can actually use one of those HDMI outputs, or again, use an extender receiver set and go into this Juno 451 switcher, which will also receive that HDR content with no problem. And I want to show you an example of what that might look like. So in the center here, we have our Opus switcher, and it is sending signal just straight to the receiver, the Opus receiver, to go to this display. But let's say in some applications, you might have some sort of multimedia room or a rec room. So we can actually go out of the switcher and into the Juno switcher, but then we still have some other localized HDR sources, maybe a gaming console or a Blu-ray player, to be able to connect all of those to this display here. So some current cables and connectors, current high-speed cables, HDMI cables, will carry the HDR signal. The source device and the TV must be HDMI 2.0A or B to transmit the metadata, but a minimum of 2.0A. And if you have a receiver and want to use it for switching, you'll also need it to be HDMI 2.0A. So a way around that would be to use our Juno series switcher and then de-embed the audio into the receiver in that way. Some adoption, Dolby Vision adoption is definitely gaining momentum over streaming services. We have Netflix, Amazon, iTunes, and Vudu are all streaming in HDR and Dolby Vision. We have some Blu-ray adoption, some new title films coming out. For players, we have the Apple 4K TV and the Google Chromecast. And even display manufacturers are also hopping on this Dolby Vision wagon with LG, Sony, Vizio, and TCL. And OmniStream R-Type for streaming, not streaming, but sending HDR content, Dolby Vision over a network. HDR has the exclusive rights to this currently, to sending Dolby Vision 60 12-bit HDR over a single gigabit network. So one thing to keep in mind when we're talking about streaming AV over IP is you can have any number of sources to any number of displays. You are not constrained by a switcher that has limited inputs and outputs. You have that any-to-any connectivity, and Cat5e architecture is supported. So if you have installations that already exist with that Cat5e cable, you can definitely utilize OmniStream over a single gigabit architecture there with Cat5e. And like I mentioned, right now, OmniStream R-Type is the first and only solution to support Dolby Vision 60 12-bit HDR. That's all that I have for you today. Rick, do you want to open up the floor? Are there any questions?
Sure, Erica, thank you very much. Yeah, I have a couple questions that came through regarding the Opus switches. And then first of all, I want to go back to your definition of HDR. Can you throw that table back up again? That has all the different bit, yeah, the different bit rates.
This one?
Maybe one before that. That talks about, which one was the one that talked about Dolby Vision?
Well, Dolby Vision is in here under 4K 60.
Oh, there we go. Yeah. Okay. All right. So we had Seth on last week when we talked about the OmniStream R, and we had a really good discussion of, for anyone who wasn't on that session, Dolby Vision and HDR10 Plus are the frame-by-frame HDR algorithms versus the traditional HDR10. It has flags that set, like, you know, at so many points during a film or so many points during a video transmission. And if you've got mixed content, let's say, I don't want to say like a documentary, but that's certainly the one that pops up where it's going from older content to modern content, HDR content to non-HDR content, the flags can be incorrect. So having HDR10 support and Dolby Vision support is really huge, because that means that your customer's always getting that best image quality, regardless of whether the content is flipping back from archived content or, you know, pre-2017 or pre-2016 content to today's content. Otherwise, what happens is if you use a less expensive switching platform that can't resolve these details and put the set into and out of Dolby Vision, is you get these crushed blacks and these bloomed whites. So that's why it's important to be able to resolve these frame-by-frame HDR formats like HDR10 Plus and Dolby Vision. And also, when you were talking about the CIE chart, we were talking about color imagery.
Yep.
I'll share an anecdote that we picked up back in the CEDIA days. So there's a perfect, there we go. If you look down on the bottom right corner past the 620, closer to the 700, that's the deepest red that the eye can see. Something that's in every one of our lives on a daily basis that is in that area is a can of Coca-Cola. Coke can red is unresolvable in NTSC or ATSC. So if your customer is especially if they're a Coke drinker, keep a can of Coke with you when you're doing your presentations, especially if you have a showroom or something like that and you're showing off a high definition, like a really high resolution panel, and set that can of Coke on the table next to the displays. It will not be able to be represented on the TV. So here's the thing: if you're looking through these chromaticity charts, the highest one that we've got right now is the Rec 2020, and the Rec 2020 gets deepest into, it's the closest to resolve Coke can red. If you look at the broad dotted line in the center, that's the old Rec 709. That was NTSC, or, you know, traditional, you know, tube televisions back in the day, the old, like, you know, Sony Trinitrons and the Mitsubishi and the Toshiba types of things. So it was nowhere near the same color red as that can. So we're in a position right now where we've got the best video displays, both projection and flat panel, that have ever existed. So it's really important to consider a high capability switching platform to deliver these high quality sources to these ultra high quality displays today. So thank you everyone for taking the time to join us on this. So the quick question that came up, you mentioned a feature set in the Opus called the HD Base T Health Monitor.
Yep,
Can you elaborate on that? That sounds pretty interesting.
sure. So we also have a couple extenders that do the same thing. And when you log into the web view of the Opus, you'll have this HDBaseT link status test. And it'll be able to tell you the distance, the health, if it's a degrading signal, um, and whatnot. So it allows you to definitely troubleshoot if you need that, but just to determine the health and the quality of the cable that's installed.
Okay. And also tell us about any to any. So basically we can take any input and route to any output
Yes,
on the audio side. So this is perfect for like sports bar environments or things like that.
exactly. So there is, you can see on the bottom, there's also Toslink outputs.
Nice.
Um, so you're able to route that in any form that you want. It could be matrixed or it could be mirrored or however you want to set it up.
Okay. And what's the easiest way to cascade if we wanted to take an 8x10 and turn it into an 8x20?
Ooh, well, you'd be limited to the first inputs. Um, I don't know that there's actually a cascading capability here,
Okay.
necessarily. But you would be able to, I mean, you'd be limited to the inputs that are on the original chassis.
Okay. So for that, we're really looking more, we're headed over toward like one of the OmniStream platforms.
Yes, exactly. And that would
Okay.
really be an any to any audio and video, any number. There's no limitation at all.
Okay. Perfect.
Yeah.
All right. And of course, we should mention the warranty.
Oh, yep, 10 years, 10-year warranty. First year has advanced replacements also. And
Okay.
that is the day that it's installed is the day that it starts, not the day that it's delivered to a warehouse.
So for any AllNet customers, if you've got a product in the field and you picked it up from AllNet within 12 months of that pickup date, or within 12 months of the install date, hopefully within a week or two after that, just reach out to your nearest branch if you've got any issues. If it's within the advanced replacement date, we'll just give you a new one, and then we'll just credit you when the other one comes back, and we'll take care of getting it returned to Atlona. And if it's past that date, then it's 10 years parts and labor. And Erica, so the process with that is we just get an RMA and we just send the unit back to Atlona to be repaired.
That is correct. The first we ask that you go through tech support first just to verify that it's being problematic, and then from there we'll send you an RMA and further that process.
Okay. And anything else interesting that you'd like to share with us? Oh, one of the things that I wanted to talk about quickly. So, and I know you touched on it here for a moment, but we do have multiple HD-based T receivers. And one of the things that Atlona offers that a lot of other vendors don't is a true 100-meter solution.
Hmm. So we actually have a couple of 100-meter solutions. You can use the 100, you can see in the top right-hand corner. Here's the 100 CEA kit, and we also have just the 100 CE if you don't need that audio return channel, but that audio return channel is actually pretty awesome. So this is a true 100 meters. It's been tested. Um, and there are a couple versions of that. And if you need to extend with the Juno, so if you notice that any of these, uh, Juno has a blue port on that HDMI, that means that it will also serve 100 meters. So on a lot of our switchers, those will extend up to 100 meters, and then the receivers will receive the same thing, not just transmitters, receivers.
I never knew the color code. See, I'm learning something as well.
Yeah.
So, oh, that's perfect.
Yeah.
Okay. Anything else interesting that you'd like to share?
No, that's about it. We have we're just ramping up for ISC coming up next year. So if you want to stay tuned with any new stuff that's coming out, definitely check us out on YouTube. We have some like unboxing videos and some new content coming out there. And that's about it.
I heard that our pal Ken likes to make videos where he unboxes all the new product.
Yes, he does.
Okay. So, okay. Oh, we did have a question that's popped up in the chat box here.
Okay.
Driver options question mark. I'm assuming that the question is in regard to the popular control systems.
So all of these have driver and API information on their product pages on atlona.com. Um, and as you may know, we also have our own control system, so all of those are available on there also.
Okay, so we can use this with Velocity, or we can use it with any
Absolutely.
of the third party, like the Crestrons, AMXs, Control Vors, Elongis, RTIs, etc.
Yes, we have open APIs for those.
Perfect. Okay. Does anyone have any additional questions? Please feel free to pose any questions in the questions box here. Okay. Well, Erica, this was short and sweet. I think you win the gold star for 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 getting right to the point.
Yeah.
So thank you very much. Thanks for your time today. Again, anyone, if you have any questions about the AllNet webinar series, please feel free to reach out to me or to reach out to Bill Zidek. And also, we're getting close to the end of the year. We're only going to have one more session for the end of the year. And actually, Atlona is going to be a part of that one as well. So next week, we're going to have Snap AV Commercial Solutions with our friend Scott from Snap AV. He's going to be talking about the new Nearest and Sense microphones and presentation camera platform, and we're going to be reviewing the CSLO platform from
Oh,
Atlona and the way that that integrates.
yeah.
So meeting rooms, presentation rooms, kind of light commercial. We know a lot of our dealers dabble in light commercial, so we want to have a high quality solution for you, something that you can install and know that it's going to work well. So looks like we're going to have Atlona 3 weeks in a row on the webinar series. It's a good time to be at Atlona. So, all right, everyone. Well, thank you for your time today. If there's anything that we can help you with, again, we will post this up on the AllNet YouTube channel. And again, that's youtube.com/AllNet Distributing U, and that's the letter U. Please consider subscribing and liking our videos and subscribing to our channel. Also, feel free to follow us on Facebook, Twitter, anywhere else we may be. And Eric, would you like to plug the Atlona pages?
Yeah, absolutely. Check us out. Obviously at lona.com, but you can find us on Facebook, Twitter, and LinkedIn.
Okay. All right, Erica, thank you for your time today.
Thank
And
you.
everyone, again, thank you for joining us on the call. And we're going to go ahead and end the webinar now. Thank you.
Thanks.